I have to get the value of BM from the diagram. So the diagonal of the parallelogram is giving me the result. Definition of cos theta, adjacent side by hypotenuse. Vector R is P plus Q. The same considerations I have made. And the line segment AC represents vector Q. Hello students, let us continue our discussion on motion in a plane, a typical derivation. Please do follow this session intensely. It is one of the favorite questions of any question paper setter. Every time in the exam and within quotes for your assessment, today's session is a typical question for 5 marks. So, as you can see, this is a very important 5 marker and this is almost asked in every exam. The aim of my bookwork today is using parallelogram law, triangle law and parallelogram law, from which using parallelogram law of vector addition, I will derive an expression. I am deriving an expression for the magnitude and direction of the resultant. Today's bookwork is to get the expression for magnitude and direction of the resultant of the two forces acting at a point. Or you can say, this is also the basic implication of the parallelogram law. Recall ಮಾಡ್ಕೊಳ್ಳೋಣ ಒಂದ್ಸರಿ. What was the statement of parallelogram law? We told if two forces acting at a common point, I'm considering two forces which act at the common point is represented both in magnitude and direction by the adjacent sides of a parallelogram. Then the resultant is represented by what? The diagonal of the parallelogram, which is drawn from the same point. So, the diagonal of the parallelogram is giving me the resultant of the two forces. Now, to begin with, students, first, I will derive an expression for the magnitude of the resultant. We will first get an expression for the resultant in terms of the two forces. So I say magnitude of the resultant of the two forces. Fine. So here if you observe, the line segment AB represents vector P. So I say the line segment AB is representing vector P. So this AB represents vector P. And the line segment AC represents vector Q. So another line segment AC is representing vector Q. So ಎರಡು ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ಗಳನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. Directed line segments AB, which represents vector P, AC, which represents vector Q. Now I complete the parallelogram. Which is the parallelogram? A, B, D, C is the parallelogram. So I'm considering A, B, D, C is the parallelogram. So vector AD, diagonal of the parallelogram, vector AD is equal to vector R. And vector R is the resultant of the two forces. So these are my initial considerations. Line segment AB represents vector P. Line segment AC represents vector Q. A, B, D, C is the parallelogram, and the diagonal drawn from the point A, AD is equal to R, which is the resultant of the two vectors. And if you observe, theta is the angle between P and Q. So very clearly, theta is the angle between P and Q. Alpha is the angle between R and P. Now going to the mathematical derivation here. So if I observe, I want this diagonal AD, that is the resultant. AD is the resultant of P and Q. So my entire show here is to calculate the resultant AD. So, by Pythagoras theorem, very simple. ADM is a right angle triangle. So, what is AD square equal to? It is AM square plus DM square. So, this is from the triangle ADM. AD square is AM square plus DM square, or AD square equals, now this AM can be written as AB plus BM. I am just separating this. So AM is written as AB plus bm whole square plus dm square, and that is what I have formulated here. AD square is AB plus BM whole square plus DM square. So AD square equals AB plus BM whole square plus DM square. Now, this is of the form A plus B whole square, A plus B whole square, which is A square plus 2AB plus B square. So I write AD square is, expand this notion, A square, AB square plus 2AB plus B square plus DM square. I am just expanding AB plus BM the whole square by using the identity A plus B whole square. So A square is AB square plus 2AB, 2AB BM plus B square, BM square plus DM square. Now observe what is BM square plus DM square from the diagram. So BM square plus DM square is Q. Opposite sides of a parallelogram are same. So this is Q square. So on rearranging, R square is AB is nothing but P plus 2P BM plus Q square, because AB is again vector P plus Q square, and I call this equation 1. Now to complete my derivation, I have to know what is BM. I have to get the value of BM from the diagram. So if you again consider triangle BDM, cos theta is basically defined as adjacent side by hypotenuse. So BDM, definition of cos theta, adjacent side by hypotenuse. So it is BM divided by BD. I want this value of BM. That is why I have defined cos. If I would have defined sine, I would have got the opposite side. So relevantly, in the previous expression, if you observe, this is what I am looking for, BM. Therefore, in the triangle, I have defined cos theta, which is BM by BD. Or BM equals BD cos theta. Just cross multiply. BM is BD cos theta. And what is BD? It is nothing but Q. So if you just observe this BD, it is Q, opposite sides of a parallelogram which are equal. Therefore, BM is Q cos theta. Substituting BM in equation 1, R square equals P square plus 2 PQ cos theta. BM was Q now. I am substituting for BM Q cos theta plus PQ square. Or R is root of P square plus Q square plus 2PQ cos theta. Kindly remember this expression. Wherever two forces act at a common point, their resultant is always R equals root P square plus Q square plus 2PQ cos theta. If you consider the two forces as F1 and F2, then the resultant of them will be root F1 square plus F2 square plus 2 F1 F2 cos theta. So the resultant of the two forces is measured in terms of cos theta. So always remember, two forces acting at a common point, their resultant will be root P square plus Q square plus 2PQ cos theta. Now, direction of the resultant. Again important, the same considerations. Vector AB is equal to vector P. Vector AC is vector Q. Vector R is P plus Q. The same considerations I have made. And from the triangle ADM, now I define tan alpha. What is tan? Opposite by adjacent. So, from the triangle ADM, I am defining tan alpha. What is tan alpha? Opposite by adjacent. DM divided by AM. So just you have to refer to the triangle ADM, tan alpha, opposite by adjacent, DM by AM. So that is what I have written here. Again, AM is split as AB plus BM. I know the value of AB, it is P. I want the value of DM and BM. From the triangle BDM, so DM is the opposite side. So when I say opposite side, I refer to sine. So sine theta is DM by BD, or DM is BD sine theta, which is Q sine theta. So sine theta from the triangle BDM sine theta is DM by BD. So DM by BD. So DM is BD sine theta. I know BD is Q, so DM is Q sine theta. Similarly, BM will be Q cos theta. Substitute in equation 2. Tan alpha will be Q sine theta divided by P plus Q cos theta. Here alpha is the resultant. Tan goes to the right hand side. It is called tan inverse now. 1 by tan kariyalla. In trigonometry you say tan inverse. So alpha is tan inverse Q sine theta divided by P plus Q cos theta. And this is the expression for good, the direction. So please to understand, we have derived a very important expression. Take your pen, take your pencil. continuously derive 5 marker. The next assessment, directly I'll be asking this. Now this is an assignment for you all. I want you all to perform this assignment. Case 1. What is the maximum possible value of the resultant? We write R is P plus Q when they are in the same direction. How? Just substitute. Look at this. You'll get an idea. Arrive at R equals P plus Q. Minimum possible value R minus Q. How? Again go through this. So as assignment, I want you all to arrive at the maximum possible value and minimum possible value of the resultant. So in my today's class, students, we have done a very, very important derivation. Have a good, intense outlook to that. My next session, I'll start with projectile motion. Until then, have a nice time. Thank you.